So welcome back to the second of our talks on the Taicaan Technologies surface analysis tool, BEX. You can see that we have the default dataset loaded here in the image space. So I'm going to start this presentation by loading another dataset. Let me just load that one. While that's loading, I'm just going to show you a photographic image of the sample that we're just going to be looking at. This is a ceramic sample. It has a series of pyramids on the surface, so this is a structured surface. The dimensions here along the horizontal line here, what I'm pointing to, is 20 millimeters and vertically 20 millimeters. So let's look at the view of this, and here you can see the data loaded from the Taicaan Technologies Zaris 2000 white light system. Just take a look at the values here. It's quite a big data set. It's 1001 by 1001, and the grid spacing is 20 microns. That means that each of these dimensions here are 20 millimeters. So quite a large sample, similar to the one that we saw previously with the fossils of the prehistoric insect wings. So a large sample. What we're going to talk about in this presentation are the key actions associated with these buttons on the top here. So let's start with that. The first one is the trash can, and if I just highlight the start data and trash that, I'm now just left with one data set, and that's the data set I've loaded. And if you look at the data set I've loaded, you can see I've already removed the plane from this data, so this is already centered around 0. The second option we saw in the previous presentation is the ability to revert back to the original data set after you have, for example, removed a plane from the surface. The third icon, the eye, takes us from a particular view to a standard view of the surface, so that when you have multiple data sets, you can always view the data sets from the same position. And then the next one is very important. It's the type of view that you can use to view the data. So let's click on that. You can see it says change to a flat surface, so I'll right click on that, and now it's changed the sample to a top-down view, and you can see that shown here. So I can zoom in again. You see a white line drawn across the center of this data, the middle point of the data set. If I just highlight the cross-section, which we saw briefly in the previous presentation, this cross-section now corresponds exactly to the white line as shown. So let's move the white line. Just drag that down, put it through the peaks of some of the pyramids here. And you can see the cross-section has been redrawn. Just look at the values here. These are millimeters, and this is the 20 millimeter cross-section. As a standard metrology tool, one of the simplest things would be to determine the distance between particular features. So if I was interested in the first two pyramids here, pointing at these with the crosshair, and wanted to know the distance apart, I can find that very easily from this cross-section here. Just click the point icon, and that gives me a crosshair positioning capability. Click on that, click on the second pyramid as shown here, and now I have the two positions of the first two pyramids, and I can see in this lower window with the light yellow coloration the distance between those, pretty much exactly 2 millimeters in X. Slight difference in Z because some of these pyramids have got slightly different heights, but basically you get the basic geometry of the sample from this. Let's turn that off. Let's hide the cross-section. Of course, the cross-section is very important in metrology, and we'll come back to this in future presentations when we focus on some of the standard parameters for characterizing surfaces. Just want to finish off coming back to the icon we were talking about here. The next view is to change from the top-down view to an orthographic view, and that's shown here. And if I click this once more, you can see it changes to the perspective view as shown. To the right of that is a slider which allows you to, well, you can see this fairly easily, just sliding this changes the amplification, if you want, of the Z values. So let's put that back to to roughly 1, which is appropriate for this particular measurement. And now, just finally, let's look at the rotation. We've seen this already, but essentially just right-clicking the mouse here, you're able to rotate the sample in the image space. Just using the central scroll wheel on the mouse, we can zoom in. So let's have a look down the avenue of pyramids here. Very nice rendering of the surface. And finally, if you just press the central wheel, we're able to just drag the surface around in the image space. So let's go back to our standard view. Yeah, clicking on the standard view. And just finally, spending a few minutes now just looking at the color scale in a bit more detail. As I said in the introduction, this particular data set had already been planed. So it's running from 1.45 millimeters through to minus 1.2 millimeters. I'm just going to show you something which we're going to cover in much more detail in the next presentation, is by right-clicking on the color scale, I have a whole range of options here. All I'm going to do here is just show you two, which are going to provide us with more information. I'm clicking on probability graph and statistical lines. What this now does is it shows you, let's expand this and make it a bit larger. What it's doing is it's showing us the distribution of the height for the particular surface that you have, with the blue line being the mean, the 0, and then the dotted lines being the standard deviations away from the mean. So +1 standard deviation where I'm pointing now, +2 standard deviations, and so on. We'll come back to this, as I said, in much more detail in our next presentation.